GCC. We're here to talk about chapter 14, which is on intermolecular forces. So let me start with this. Have you ever wondered what makes water stay down in the ocean? Why doesn't the water molecules just fly up and float away and go away? What keeps it together? What keeps us solid like a desk? What keeps us solid together? Why don't the molecules just turn into gas and float away? Well, the answer of what is holding these things together in many cases is intermolecular forces. So obviously they're very important because they're holding water together down in the ocean and in lakes and streams. They're keeping solids together. So intermolecular forces are actually very important. So this is an important chapter. So intermolecular forces are abbreviated IMF. You may see that abbreviation. Bonds hold atoms together within a single molecule. So I want to clarify bonds and how they're different from IMF. So again, bonds hold atoms together within a molecule. Now, what is holding molecules together is the intermolecular force. So if you look at that picture, the black dots in the blue circle, those represent two atoms. And you can see the bond is pointing to what's holding those two atoms together within the blue circle. Now we have two blue circles. That's two molecules. The red dashed line is some sort of attraction between those blue molecules. That is the intermolecular force. So what holds those two molecules together, perhaps, is called an intermolecular force. Now, forces are always weaker than bonds. Bonds are much stronger than a force. For example, when you run your hand through a tub of water or a swimming pool of water, you're not breaking the bonds in water. What you're doing is your hand is going between the molecules. It's breaking the intermolecular forces. And then as soon as your hand passes by, the water snaps back together again. So those are forces that you're breaking, not bonds. You're not breaking water bonds when you run your hand through some water. Now, we need to review a little bit about bonds in this chapter. So let's remind ourselves, ionic bonds are between a metal and a non-metal, metal and a non-metal. The non-metal could be a polyatomic ion, for example. Remember, metals lose electrons and the non-metals gain the electrons. So metals lose electrons and become positively charged cations, and the non-metal will gain those electrons and become negatively charged anions. So basically, electrons transfer from the metal to the non-metal, that in an ionic bond. So the metal's positive, the non-metal is negatively charged, and opposites attract. There's an attraction of opposite charges. Now, a covalent bond is two or more non-metal atoms, non-metal bonding. Now, covalent bonding can be divided into polar and non-polar. So just a quick review on that. Polar is when you have two different nonmetals, like X to Z. So nonmetals again are on the right side of your periodic table. So polar bonds would be C to O, N to F, S to Cl, P to O, Br to F. Those are polar bonds. They're different nonmetals. The electrons are shared in a covalent bond, but in a polar covalent bond, they're shared unequally. One of them is closer to fluorine, and so that nonmetal pulls the electrons closer to it. Electrons are negative, so that atom is a little bit negatively charged. We represent that with a delta minus. Delta minus. So it's a little bit negative. The other atom, the electrons are not close to it, so by default, it's a little bit positive, delta plus, a little bit positive charge. So the bond has a little bit minus and a little bit positive ends. So we have opposite charges, right? So we have poles. It's like poles of a magnet. We have a plus and a minus end. So it has two poles, so it's polar. Now let's review nonpolar. Nonpolar is when you are bonded to yourself and you're a nonmetal compound, like O to O, P to P, Br to Br, F to F. So if you're bonded with yourself, the electrons are shared equally. Also, CH bonds are nonpolar. Those are an exception. So no one's pulling the electrons closer. It's like a tug of war that's a tie. So there's no poles. The electrons are right in the middle of the two atoms. No poles. No poles means non-polar. So remember, you can think of polarity as a tug of war. Whoever is closest to fluorine wins that tug of war and pulls the electrons close. But if you're having a tug of war with yourself, the tug of war is a tie and you're non-polar. All right, good. So bonds versus intermolecular forces. If we have one HCl molecule, what is holding the H atom to the Cl atom is a polar covalent bond, represented by the yellow dash. But if we have a sample of thousands of HCl molecules, what holds the molecules together is intermolecular forces. That is represented by the white dashed line. So forces hold molecules together, bonds hold atoms together. All right, good job. So intermolecular forces, there are 4 of them that we're going to learn in Chem 130. And all of the intermolecular forces are attractions between opposite charges. Often it's the polar bonds that have a little bit plus and a little bit charge in the molecule, and we put 2 or more of those molecules together and they form attractions. So intermolecular forces are attractions between oppositely charged parts of 2 or more molecules. Note, you can't have an intermolecular force with one molecule. You have to have 2 or more molecules to have an intermolecular force. The intermolecular forces are 1, London dispersion forces. Some people abbreviate that LDF. Some people call it dispersion forces. Some people call it London forces, like myself. The complete name is London dispersion forces, LDF. Number 2 is dipole forces, abbreviated DDF. And yes, you have to say the word dipole twice. Dipole forces. Number 3, hydrogen bonding forces, HBF. Some instructors call this hydrogen bridging forces. So both of those are the same thing. You may notice in an older video, I call it hydrogen bridging force. In this video, I'm going to call it hydrogen bonding force. And then the last one, number 4, is ion dipole forces, IDF. So you have an ion and a dipole, a polar molecule, and there's an attraction between those. All right, in the next video, we're going to talk more about these 4 forces in depth. See you next time.